In today's lesson, we're going to talk about adding and subtracting expressions. And in our first example, we're told that Delilah signs up for a health club and a rock climbing gym. They want to know what expression represents her total fitness cost after M months. And so we can see two different places. We can see Rudy's Rock Climbing and Ace Health Club. And each place has an initial startup fee that Delilah has to pay, along with a monthly fee that she's going to have to pay. And what I need to do is come up with an expression that's going to represent Delilah's costs after M months for each place. And then to find the total fitness cost, I'm going to have to add those two expressions together. So let's start with Rudy's Rock Climbers. All right, so for Rudy's, all right, well, we're told that she has to pay a $65 initial fee. So we're going to start with $65. And then we're told that she has to pay $40 for a monthly fee. So $40 for each month. That means she's going to have to pay $40 for every month. So I'm going to multiply it by M, the number of months. And to get her total cost for Rudy's, I would have to add these values together. So for Rudy's, 65 plus 40M represents her fitness cost. We have to do something similar for Ace Health Club. So for Ace, okay, well, the initial fee for Ace is $80. She has to pay that up front. And then it's $50 per month. So 50 times M, the number of months. And again, to get the total for Ace, I would have to add these values together. And now if I want her total fitness cost for both places combined, I have to add these two expressions together. So I'll take Rudy's, which was the 65 plus 40M. And I'm going to add that to Ace, which is 80 plus 50M. Okay, well, I put them in parentheses here to keep them separate. And remember, there's an invisible 1 in front of each set of the numbers here. So if you were to distribute 1 to all of these terms, well, these terms aren't going to change at all. Okay, so it's still going to be 65 plus 40M plus 80 plus 50M. We're going to rearrange our terms so that our similar terms are together. So we're going to have 40M plus 50M plus 65 plus 80. And now I'll combine my similar terms. 40M plus 50M is 90M. And if I add the constants, 65 plus 80, that's plus 145. And so this expression right here represents her total fitness cost after M months. She's paid a total of $145 in initial fees, and between the two places, she's paying $90 per month. In our second example, we're told that Cindy spent $125 on ingredients for muffins and $92.40 on ingredients for bagels. Write an expression to represent Cindy's profit for M muffins and B bagels. Okay, so the way that she's going to make a profit is by selling her muffins and bagels. And you take the amount that she earns from selling those things, and you have to subtract off the amount that she spent on the ingredients to figure out what the profits are going to be. So let's start with the muffins, okay? So for her muffins that she's making here, we can see that she earns $2.40 for every muffin that she sells. Okay, so we're going to take the price per muffin, $2.40, and multiply it by M, the number of muffins. This would represent the amount earned by selling the muffins, but we have to subtract the amount that she spent on the ingredients for the muffins, which was $125. So you take the amount that she earns for selling the muffins and subtract off the ingredients, and what's left over would be her profit. So this expression represents the profit for selling M muffins. For bagels, we're going to do something similar. Okay, we can see on the sign that she earns $1.80 for every bagel that she sells. So we're going to take the price per bagel, which was $1.80, and multiply it by B, the number of bagels. But again, we have to subtract off the amount of the ingredients for the bagels, which was $92.40. So minus $92.40. So this expression right here represents the profit from selling B bagels. That's how much she would earn from selling the bagels minus the ingredients. So that expression is her profit for the bagels. Now we want to get the total profit from the muffins and the bagels combined. So again, I'm going to take my muffins, which was $2.40 M minus 125. And I'm going to add that to the bagels, which was $1.80 B minus $92.40. And I need to add these two values together. So again, there's ones in front of each set of parentheses that if you were to distribute, these terms wouldn't change. Okay, so I'm going to list my terms in order. All right, I've got muffins, I've got bagels. Alphabetically, B comes before the M. So I'm going to start with $1.80 B plus $2.40 M. And now my constants will go at the end, minus 125 minus $92.40. Okay, well, with my variable terms, these are not similar. Bagels and muffins are not similar, so I can't combine these, but I can combine my constants down here at the end. So I'm going to have $1.80 B plus $2.40 M. And then these are same signs, so we're going to add them together. Negative 125 and negative 92.40 is negative, so minus $217.40. And so this is the expression that's going to represent Cindy's profit from selling M muffins and B bagels. She's going to earn $1.80 for every bagel, plus $2.40 for every muffin, minus the total of the ingredients together, which was $217.40. In example 3, we're going to find the sum by adding these two expressions together. Okay, 1/2 x minus 3 minus 2y plus 1/4 x minus 2y plus 5. So I need to add these two expressions together. Notice the parentheses. Remember, there's a 1 in front of that, and there's a 1 in front of that. So if you distribute 1 to each of these terms, they're all going to stay the same. If you distribute 1 to these terms, they're all going to stay the same. So we're going to go ahead and rearrange our terms so that our similar terms are together. So I have a 1/2 x that I'm going to start with, 1/2 x, plus over here's a 1/4 x. I'll put them next to each other. Those are my variable x terms. Okay, and then I have a minus 2y, and another minus 2y right here. So my y terms are together. And I'll get my constants together. I have a negative 3, so minus 3, and a positive 5. That goes at the end. Okay, so now let's combine the x terms together. 1/2 x and 1/4 x, these are fractions. In order to add them together, I need to have a common denominator. Halves and fourths, I'm going to use fourths. 1/2 is the same as 2/4. So this is 2/4 x plus 1/4 x. And then again, minus 2y, minus 3 plus 5. So when I combine these, they're same signs. I'll add them together. 2/4 x plus 1/4 x is 3/4 x. Okay. Now when I go ahead and combine my y terms here, negative 2y and negative 2y, they're same signs, so I'm going to add them. That's going to give me negative 4y, so I'm going to have 3/4 x minus 4y. And then I'm going to combine my constants together, negative 3 and positive 5. They're different signs, so I'll subtract. 5 minus 3 is 2, and it's going to be positive because 5 has the bigger absolute value. So since it was a positive 2, I'm going to write plus 2. And there is our expression, 3/4 x minus 4y plus 2. In example 4, they want us to find the difference this time, so it's a subtraction problem. So I have 95/100 x minus 4/100 minus 99/100 x minus 13/100. So again, now they're in the parentheses. I have a 1 in front of this set of parentheses, but in front of this set of parentheses, I now have a negative 1. So this is going to be different than the problems that we've done before. When I distribute 1 to these two terms, they're not going to change. So I'm still going to have 95/100 x minus 4/100. But now I need to distribute negative 1 to these two terms. So I'm going to have minus 1 times 99/100 x minus 1 times, that's a negative 13/100. So I'm going to write down my first two terms again, 95/100 x minus 4/100. And now when I do this multiplication, negative 1 times 99/100 x is negative 99/100 x. Negative 1 times negative 13/100 is positive 1300ths. So the signs of these two terms changed from what they were originally. This was originally positive, now it's negative. This originally was negative, now it's positive. Now we'll rearrange it. I have 95 hundredths x minus 99 hundredths x minus 4 hundredths plus 13 hundredths. And now I'll go ahead and combine my similar terms. With my variable terms, these are different signs, so I'm going to have to subtract. 99 hundredths x minus 95 hundredths x is 4 hundredths x. And it's going to have to be negative because negative 99 hundredths x has the greater absolute value. When I combine my constants, negative 4 hundredths plus 13 hundredths, again, they have different signs, so I'll subtract. 13 hundredths minus 4 hundredths is going to be 9 hundredths. And it's going to be positive because the positive 13 hundredths has the greater absolute value. And so this is our final expression when we combine them, negative 4 hundredths x plus 9 hundredths. In example 5, we're again find the difference. So this is a subtraction problem. So remember, there's a positive 1 in front there. There's a negative 1 in front there. Distributing this 1 to these three terms will leave them unchanged. So it's going to be 5j minus 2q plus 2/5. Now let's distribute negative 1 to each of these terms. So minus 1 times 4, minus 1 times negative 3j, minus 1 times negative 1/2 q. Okay, I'll write down my first three terms again since they're unchanged. 5j minus 2q plus 2/5. And now when I multiply, negative 1 times 4 is negative 4. Negative 1 times negative 3j is positive 3j. And negative 1 times negative 1/2 q is positive 1/2 q. Okay, so let's go ahead and rearrange our terms now. So when we do that, we're going to have the j terms first, 5j plus 3j. Then the q terms, minus 2q plus 1/2 q. And then the constants at the end, plus 2/5 minus 4. Okay, so if we can go ahead and combine now, we'll do the j terms first. 5j plus 3j, that's 8j. With my q terms, I have negative 2q plus 1/2 q. All right, I can turn that into negative 2 over 1, so that these are fractions. I need a common denominator. Firsts and halves, I'll use firsts, or excuse me, I'll use halves rather. So this will be the same as minus 4/2 q plus 1/2 q. Okay, and then I might as well do the same thing while I'm over here with my constants. Okay, I'm going to make that 4 over 1. So I have fifths and firsts. I'm going to use fifths as a common denominator. So that's going to say plus 2/5 minus, all right, that's going to be minus 20/5. So I'm still going to have my 8j. I'm going to bring that down. And now when I combine my q terms, these are different signs, so I'm going to subtract. 4/2 q minus 1/2 q is 3/2 q. And it's going to be negative because negative 4/2 has the bigger absolute value. And then with my constants, again, these are different signs, positive and negative, so I'll subtract. 20/5 minus 2/5 is going to be 18/5. And it's going to be negative because negative 20/5 has the greater absolute value. And now all I'm going to do is rewrite this again so that my fractions are going to be mixed numbers since the numerators are bigger than the denominators. So I'm going to still have 8j. Okay, 3/2 is the same as 1 and 1/2, so minus 1 and 1/2 q. And then minus 18/5. 5 goes into 18 3 times with 3/5 left over. So our final expression says 8j minus 1.5 q minus 3/5. In number 6, again, we're going to find the difference. All right, we have 17 plus 4.5m plus 8k minus 7.5m minus 9 plus 4k. So there's a 1 in front of that first set of parentheses, a negative 1 in front of that second set of parentheses. Distributing 1 to these terms will leave them unchanged. 17 plus 4.5m plus 8k. Now distribute negative 1 negative 1 times 7.5m, minus 1 times negative 9, minus 1 times 4k. And again, this is 17 plus 4.5m plus 8k. Negative 1 times 7.5m is negative 7.5m. Negative 1 times negative 9 is positive 9. Negative 1 times 4k is negative 4k. Now we can rearrange it. All right, variable terms first alphabetically. K comes first. So we're going to have 8k minus 4k. Now the m's, plus 4.5m minus 7.5m. And now the constants, positive 17 plus 17, and then plus 9. So now when we start to combine 8k minus 4k, that's going to leave us with 4k. 4.5m minus 7.5m, these have different signs, so I'm going to subtract. 7.5m minus 4.5m is going to be 3m. And since the negative number has the bigger absolute value, I'm going to put a minus sign there. And now with the constants, I have 17 plus 9, same signs. I'm going to add them together. 17 plus 9 is positive 26. Excuse me, yeah, positive 26. And so there is our expression, 4k minus 3m plus 26. In our last example, we're told that Jada is comparing membership costs for 2 gyms. What is the difference in membership costs after M months if she joins Be Strong instead of the Zippy Health Club? So this is going to be very similar to what we did at the very beginning of the lesson. I have to first figure out what the monthly costs are going to be at each place. And now if I want the difference, I'm going to have to end up subtracting them. Okay, so we're going to take a look at Be Strong. Be Strong. Okay, and that's this one right here. Okay, and we're told that it costs $24.99 per month, and you get $10 off for the first month. So we're going to take the monthly cost, $24.99, and multiply it by M, the number of months. And we get to save $10 one time off of the first month, so minus 10. That represents the cost of joining Be Strong. All right, at Zippy Health Club, we're told here that it's $49.95 to join, and then it's $19.95 per month. So we're going to have the monthly cost, $19.95 times M, the number of months. And we had to pay an initial fee, so plus the initial fee, which was $49.95. All right, they want to know, again, what is the difference if she joins Be Strong instead of the Zippy Health Club? So we're going to take the Be Strong, which was $24.99M minus 10, and we're going to subtract Zippy's, which was $19.95M plus $49.95. So again, this is similar to what we were doing before. There's a 1 there. There's a negative 1 there. This is going to keep the first two terms the same, $24.99M minus 10. We'll distribute the negative 1 to these, so minus 1 times $19.95M minus 1 times $49.95. And then if we go ahead and distribute, again, this is going to stay $24.99M minus 10. Negative 1 times $19.95M is negative $19.95M. Negative 1 times $49.95 is negative $49.95. Okay, let's go ahead and rearrange. We're going to have $24.99M minus $19.95M. And then the constants, minus 10 minus $49.95. And now if we go ahead and we combine those similar terms. So I'm going to start with my variable terms. $24.99M minus $19.95M is 5 4/100ths. And then with my constants, they're the same sign, so I'm going to actually add them together. Negative 10 and negative $49.95 is negative $59.95. And so this expression right here represents how much she would save after M months. Okay, she would save $5.04 every month, and a total of $59.95 if she joined at Be Strong rather than at the Zippy Health Club.